All right. Hello again. Welcome to Unit 2, Lesson 2. We're going to be talking about the title of this Brad Paisley song, Water. Okay? I wanted to do this. You can thank Marcus Steinloggy. He wanted a little music in the background. I thought I'd do one better. Go ahead, throw a little music video on for you. Okay? This is a good song. I kind of like this song. All right? Not a bad one. Doesn't talk anything scientifically about water, like we're going to discuss today. But it does, touch on the subject that we are going to discuss, which is water. Okay? So, boy, do we take this stuff for granted. All right? We take this water stuff extremely, extremely for granted. All right? So, some quick facts about water and maybe how we take it for granted. Okay? You can actually drink up to 3 gallons of water a day. A healthy human being could consume up to 3 gallons of water a day, but don't do too much because there is such thing as water intoxication, which means you have too much water in your bloodstream and it throws off your sodium levels, therefore adjusting the water balance inside your brain, which would be dangerous to your health. There's more fresh water inside the ground, underneath the ground, in aquifers than there is on the surface of the earth. And last but not least, Americans estimated to use about 346 billion gallons of fresh water a day. 346 billion gallons. That is a ton of water. So we definitely take this stuff for granted, all right? So some just quick little water facts for you. A little music video about water. But let's go ahead and let's get to discussing why we're going to talk about water. It's so dang common, and you've known about it since you were a little child. You studied in grade school, and last year in general science we looked at it in its 3 different states: solids, liquids, and gases. Water is something we see and interact with daily. It's all around you. Heck, it makes up 70 to 75% of your body at any given point in time. So is it important? Oh yeah, you bet it is. Do you know a lot about it already? Yes, you do. So today we're going to examine, though, the chemical and biological secrets of water. Topics that are going to be covered. And let's hope I get these sheets on here correctly. Topics that are going to be covered. We're going to go ahead and we're going to look at water's polarity. We're going to check out water properties. We're going to examine the solvency power of water, how it's considered the universal solvent. And finally, we're going to look at water as a buffer, how it interacts with acids and bases. Okay, so these are the 4 major topics we're going to look at today. All right? Water's polarity, the secret properties of water, water as a solvent, and buffers. Okay, how water is a buffer. All right. So let me pose you a little situation here. Maybe some natural phenomenon that you never thought of, but how the chemical structure of water causes this. So it's a rainy day. You're driving to school. All right. You're driving to school. And it's a rainy day. Water is dropping from the sky down onto your windshield, and it's slamming down on that windshield. You turn your windshield wipers on and observe the rubber arms swatting the water away from the glass. Between the swipes, though, okay, across your windshield, you observe how droplets, I'm talking about here, how little droplets kind of cling to one another. You know how the water beads race down, and then it's a little bit of a trail? Why is that? Why is the water just not splattering right off of it? Why is it not just staying as individual droplets? Why do smaller droplets combine with other small droplets to form bigger droplets than trails? How does that happen? Okay, so think for a second here. Kind of looks like little magnets, doesn't it? Why does water droplets almost act like little magnets? Well, because water's chemical structure is somewhat similar to that of a magnet. It's called polarity, and water has it. Alrighty? Polar, or polarity, okay? Any compound or molecule that has a slightly positively charged end and a slightly negatively charged end is considered polar, okay? That's our definition of polarity. Something important right here. Now I'm going to show you what it looks like with water, okay? So we draw our atomic model of water, that Lewis dot diagram, all right? And we know that oxygen has 6 valence electrons. Each hydrogen atom has 1. H2O, 2 hydrogens, 1 oxygen. So they're covalently bonding, all righty? So if you examine the atomic structure of water, it's going to make sense a little bit here of why water is polar and how it has a slightly positively charged end and a slightly negatively charged end, and it looks like a little magnet. Alrighty? So we examine this a little closer here, and we can see that the electrons from the hydrogen Well, they get closer to the nucleus of the oxygen atom because there's 8 positive charges down here. These electrons from these hydrogens give in to peer pressure. They give in to atomic peer pressure. You've got these 8 positive protons. Come on, come hang out over here. It's cooler. There's more of us. You'll enjoy it more. There's only 1 positive proton over here at the hydrogens. Okay? There's only 1 for each there. So this electron gives in to the peer pressure, is pulled closer to the stronger positive charge, therefore giving this in a more negative charge. Because all of a sudden you have 10 electrons gathered around the oxygen, 10 electrons closer to the oxygen atom, no electrons closer to these hydrogen atoms. Therefore, you have a slightly negatively charged end towards the oxygen and a slightly positively charged end towards the hydrogen. Hence, water being what we call a polar molecule. It's like a little magnet. It's almost like our globe, how we've got the north and south poles and the magnetic north and south poles. Okay? Poles, polar, polarity, not referring to it being super cold, okay, referring to its natural electromagnetic attraction ability. Okay? So, a little bit about water's polarity there. All right? Now, because of water's polarity, it allows it to have certain secret, really, really special properties. Okay? It's this polarity that allows water to do so many amazing things, i.e. the water droplets combining and growing larger with one another on your windshield. Okay? There's 4 major properties that we're going to talk about. All right? 4 major properties that we're going to talk about. For instance, water's ability to attract to itself is known as cohesion. Okay? Water's ability to attract to itself is known as cohesion. Because again, water being a little magnet, one water molecule being that little magnet, it can attract to several other water molecules. That's cohesion. Adhesion would be water, and due to its polarity, attracting to other polar substances. Okay? Adhesion is water adhering, okay, water molecules attracting to other polar substances. Capillary action is a property that water has and can carry out, comes kind of in action, okay, it's a verb, it's a thing, and it's due to water being able to adhere and cohere, okay, so water is adhering to other substances, it's cohering to itself, so it's attracted to itself and other substances at one time. So water can actually travel vertical, all right, water can physically move vertical because of the natural chemical attraction that is established because of its polarity. All right, pretty special stuff. You got to wonder how a plant gets water up to its fruits. It's capillary action. All right, it's capillary action. How the heck does a plant get water from the ground all the way to the top of the tree? Capillary action. The last little secret we have here is surface tension. You ever seen a bug run across the top of a creek, of a lake, of a river, of a stream? It's due to surface tension. With the assistance of gravity and the fact that water coheres to itself, water actually has somewhat of a tight top, if that makes sense, all right? So if you don't have over a certain amount of mass, you can actually sit on top of water because of the, again, polar attraction and gravity. Water kind of has a little bit of a lid on it, all right? So it's called surface tension, one of water's special properties there. Now, one question you might have is, well, what do we call the bonds that form between water molecules and water molecules and water molecules and other polar molecules? It's a great question. We've already looked at ionic and covalent bonds. Okay, we've looked at ionic and covalent bonds. Ionic being slightly weaker, covalent being really strong. And again, it's a giving or taking or a sharing of electrons. Well, we don't have any of that going on with water. Okay, we don't have any of that going on with water. The only thing we have going on with water is that natural positive to negative attraction. And we call that a hydrogen bond. Okay? Hydrogen bonds are the weak bonds formed between polar molecules. All right? It's just a bond created between natural positive and negative charges. Easily broken, easily formed, which again allows water to do a couple other things, which are the last 2 topics here in this video. Because water can easily form and easily break down polar bonds, it's known as the universal solvent. Okay? It's known as the universal solvent, all right? Water's polarity causes it to break things down physically. And I use the old Kool-Aid example here. Okay, sugar in the powder Kool-Aid form, those would be considered your solute. They're polar substances, all right? They have slightly positively and negatively charged areas. So all of a sudden water comes in, there's a lot more water molecules, and these water molecules, peer pressure, all right, subatomic peer pressure here, these water molecules start pulling away at these other polar substances, physically breaking it down, going from that large sugar to much, much smaller, simpler sugars. All right? So water is considered a universal solvent in that it can break down physically many different polar solutes. Solute plus a solvent gives us a solution. Kool-Aid packet, sugar, solute, water, solvent, the solution, delicious Kool-Aid. All righty? Last but not least, water as a buffer, okay? Water as a buffer, all right? Similar to how water's polarity allows it to physically break down some solutes, okay? Water's polarity can also have it calm down or tame, dilute acids and bases, all right? Acids and bases are usually liquid substances that we refer to as either having a lot of hydrogen ions or hydroxide ions, okay? Acids are substances that have a high concentration of hydrogen ions. Bases are substances that have a high concentration of hydroxide ions. The chemical structure of hydrogen ions and hydroxide ions make them highly reactive. The more H plus or OH minus, the more reactive and nasty the substance is. Because of, you guessed it, water's polarity, it has the unique ability to act as a buffer. We call it a buffer, okay? It's kind of like injecting itself in the middle there so that it's not nearly as reactive. It's a buffer and it can dilute some of these highly acidic or highly basic substances. We label substances as either acidic or basic by where they fall on the pH scale, which you can see here at the bottom, okay? Anything between 0 to 7 is considered very, very acidic and an acid. It has a lot of hydrogen ions. You get closer to 7, you decrease in the amount of hydrogen ions. You get closer to 0, you really increase in the amount of hydrogen ions. Anything from 8 to 14 is regarded as basic. So a low amount of hydroxide ions here to a very high amount of hydroxide ions over here. Anything in the middle is considered neutral. Now where might water fall? Well, if it's a buffer and it can tame each one of those down, water falls right in the center, okay? Water is a buffer, falls right at 7 in the center. So that puts a kibosh here, puts an ending here on water information. Make sure you have a solid understanding of what water's chemical structure is and how it has many special properties that result from it, okay? Your lab and activity that you're going to do for this lesson is all about water and its special properties, okay? Your note requirement for this video is another WSQ. Let's practice it. We did it with the first lesson. Let's do it again here, all right? So watch, go ahead and summarize. Got that little superscript 4-sentence summary, okay? And 2 more questions, all right? Another little superscript, okay? So a little WS to SO to the 4th power Q squared, all righty? I also want you to include a actual chemical diagram of water. I want you to draw a Lewis dot structure of water and kind of why it is a polar molecule. I want you to understand the chemistry behind how it is like a little magnet. It has a slight positive and slightly negative charge in. Okay? That does it for this video. Leave you with a little Brad Paisley. A little water. Okay, a little water. See you in class.